Hi everyone, and welcome back to yet another lesson in Python programming. In today's lesson, we're going to focus on NoSQL databases. We are already familiar with the concept of relational databases such as SQL databases. However, in today's lesson, we are going to shift our focus to working with unstructured data. Now, the objectives for today's lesson is as follows. We'll first discuss NoSQL databases in a bit of detail. Next, we'll move on to differentiating between structured and unstructured data. And lastly, we'll wrap things up with a practical demonstration where we'll create a NoSQL environment using Firebase. So, what exactly are NoSQL databases and how do they work? Well, in essence, NoSQL databases utilize various data models to store and retrieve data. Unlike relational or SQL databases, NoSQL databases are a type of database management system that differs from traditional relational database models. While traditional databases are based on the SQL or structured query language model, NoSQL databases are ideal for dealing with large datasets, especially datasets that need to be processed with efficiency and performance in mind. However, they are better equipped for unstructured data and not structured data. Some of the characteristics of NoSQL databases include the following: schema flexibility. Unlike relational databases that require a predefined schema, NoSQL databases offer flexible schemas. This means that you can store different types of data without a fixed structure, making it much easier to handle evolving and unstructured data. These types of databases also include horizontal scalability. NoSQL databases are designed to scale horizontally, meaning that they can handle large amounts of data at high traffic loads by adding more commodity servers to a distributed system. These types of databases also include high performance. NoSQL databases are optimized for handling vast amounts of data and high-speed data retrieval. They typically prioritize read and write performance over strict data consistency, making them well-suited for applications that require real-time data processing and high throughput. Lastly, the architecture tends to be more distributed. NoSQL databases are often designed as distributed systems where data is distributed across multiple nodes or servers. This distribution allows for fault tolerance and high availability, as the failure of one node does not result in complete failure of the system. Now, usually when we work with databases, we tend to work with different types of data structures. This can include both structured and unstructured datasets. Structured data is organized and formatted according to a predefined schema or data model. It is typically stored in a relational database or even spreadsheets where data is organized into tables with rows and columns. Structured data also follows a specific format and has a fixed schema that defines the data types and relationships between data elements. It can be easily categorized, classified, and processed due to its consistent structure. Examples of structured data include tabular data in databases such as customer information in a CRM or a customer relationship management system, sales transactions, inventory records, as well as financial statements. Unstructured data, on the other hand, is significantly different. Unstructured data lacks a predefined structure and does not conform to a specific schema or data model. It is often characterized by its free-form nature, making it challenging to organize and analyze using traditional database management systems. Therefore, data has very little direct correlation. Unstructured data can take various formats such as text documents, emails, images, videos, social media posts, audio recordings, and so much more. It does not adhere to a fixed format, and the information it contains may not be easily extractable without specific processing techniques. Because these databases are quite efficient, they easily accommodate robust application development. Now with that said, it's time for our practical demonstration where we'll learn how to set up our NoSQL environment. And to set up our database environment, we're going to use one of my favorite cloud database platforms, Google's Firebase. So without further ado, let's dive right in. Now to get started with setting up your Firebase environment, you can simply run a search in Google on Firebase. The first result is generally what you are looking for. So you'll also need a Google account to proceed. I've already signed in with my account, so therefore I can proceed as usual. Now let's just take a quick moment to have a look at some of the features that Firebase has to offer. So Firebase is an app development platform that allows you to store data, build applications, perform machine learning, and so much more. If we have a look at some of the solutions, we can actually build on the cloud. We can also monitor the statistics of our users and our app engagement, and we also have an opportunity to integrate with various other Google Cloud Platform services. Apart from this, we can also integrate Firebase with Slack, Jira, and Android Studio, which is one of my favorite because integration with Android Studio allows you to build applications natively for your mobile device and host that data on the cloud. If we navigate to the Products tab over here, here are some of the additional features included. So we have access to a real-time database. Notice that we can use JSON inside of this database, which we are already familiar with. And this is what we are going to be doing in our next lesson when we start scripting. We are going to be working with the real-time database. There's also an opportunity to perform remote configuration, Firebase extensions. We can develop cloud functions. We can even authenticate users for applications, whether that's web or mobile applications. We can store files such as images, audio, and videos as well. Apart from this, we have access to cloud messaging and hosting services. And one of the most powerful tools is Firebase ML or Firebase Machine Learning, where we can develop machine learning features on the cloud. Great. So now that we've got a brief overview, what we need to do next is navigate to our console. So I'll click on Go to Console, and this is where I can set up my Firebase environment. The next thing we have to do is add a project. So I'll click on Add Project over here, and you want to give your project a name. I'll call this Books-DB-Demo. You can name this whatever you'd like. I'll click Continue. And then I'll enable Google Analytics for the time being. This is not necessary. It's not a requirement. You can always add this feature at a later stage. I'll then click on Continue. And now I need to select an account. I'll select the default account for Firebase, and then I'll create the project. Now this will take a couple of seconds or a couple of minutes. Great. So once your project has been created, you can go ahead and click on Continue over here. I'll now be redirected to the actual console, and this is where I can start building out my applications. Notice that I can build for authentication, as we mentioned, for real-time databases, for Firestore databases. In our next lesson, we're going to focus on using the real-time database. I strongly suggest that we experiment with some of these features, especially if you are building out your own project, which might need some sort of authentication, database features, storage, hosting, and machine learning capabilities. If you are already accustomed to working with NoSQL databases such as MongoDB, you'll feel right at home with Firebase. What's really great about Firebase is that it's fairly lightweight and free to use within specific usage parameters. So in today's lesson, we learned the basics of NoSQL databases as well as unstructured and structured databases and how they vary in terms of the advantages and disadvantages. In our next lesson, we're going to learn how to develop a book management system using Python and the Firebase real-time database. So for all of that and more, I'll see you in the next lesson. Cheers.